Hello all, welcome to this course Managing AWS with Terraform. In this section of video, what we are going to learn, we are going to deploy this infrastructure via Terraform. So in the previous video, we have seen how to create a VPC, how to create a multiple subnets, multiple VPC. Now we are extending our infrastructure so that we can learn more and more. So this time what we will do, we'll create a VPC from the scratch, then we'll create a 4 subnets and 2 subnets in each availability zone. One will be public, one will be private, and this will be your in US East 1A, and this subnet will be in the US East 1B. Okay, then we'll create an internet gateway so that all our traffic for the internet for the public subnet will flow from internet gateway, right? And then we'll create a route table also, and then we'll associate these 2 subnets with this route. Same way for this, we'll attach a NAT gateway, and for NAT gateway we need elastic IP, so we'll create elastic IP as well, and then we'll create a private route table here so that we can have a flow from private network via NAT gateway. All right, so let's get started. So as you know that now our infrastructure is getting bigger and bigger. So what I'll do now, I'll use this Visual Studio Code to write my codes. Okay, so you can use any editor, and then once my code is finished here, I'll push this code to my Terraform server, and then I will deploy. I'll push the code here. So I see there is nothing here, so once I'll write my code here, I'll push this code, and this code will come here, and then from here we'll deploy. All right, so let's get started. Let's create a folder called networking, because these are all networking components, right? And then inside this, create a file called main.tf. okay, so in this file, first thing what we need to create is the VPC, right? And then once the VPC is created, we'll create a internet gateway, and once gateway is created, we'll create an elastic IP, and then we'll create a subnet. So first thing first, let's create a VPC. So we'll have the code same provider, right? Provider will be your AWS, and region will be US East 1, right? So this will be your provider, AWS US East 1. The next thing is we need to create VPC. So now this time I'll do a comment, and then I'll write create a VPC, so that each section will have a comment what we are doing. So in the previous video we have seen this is the code where this is how we created a VPC, right? The name was DC1. I'll keep the name same, VPC, and the CIDR block will be 10.10.0.0 and /16, and tag again I'm giving the DC1. All right, now the next will be we need to create an internet gateway. So this is new, so let's see, I'll say create internet gateway. This is the command. Okay, so now to create an internet gateway, we need to use another resource which is called AWS Internet Gateway. So if you see your resource AWS Internet Gateway, and this is the logical name, I can give any name whatever you want, and the same name will be referenced in the output if you are going to display this information. And when we are creating an internet gateway, you tell in which VPC you are going to create. So VPC ID will be accessible via AWS VPC.dc1.id. So we'll get the ID for this VPC, and that's what we are allocating here. And again, tag name you can give whatever you want, so I'll just give DC name DCIZ1. Okay, all right, the next resource will be what, to create a elastic IP, right? Then so that we can associate with this in the NAT gateway. So let's say I say create elastic IP. Okay, so to create an elastic IP, the resource name is AWS_EIP. AWS_EIP. So what it does, it's create a elastic IP. That's all. That's the smallest code which you can say. Okay, so we are all set here with the elastic IP. Let's go to our diagram and see. So we have created a VPC, we have created internet gateway, we have created elastic IP. Let's create a subnet. So all these 4 subnet, 2 public and 2 private. Okay, so I would say create subnet. I can put it here. Okay, all right, so subnet creation. So first of all, let's fetch the availability information. So we did with the data resource in the previous videos. See, this way, right? Data AWS availability zone, and this is how we are going to access the availability zone. Since we need to create this availability zones in 1A and 1B, right? So 1A and 1B, so the name will be 0 and 1. The list will be reflecting with the 0 and 1. Okay, I'll just quickly paste the code. So here I'm going to create, I'll just put a site block and create subnet, create public subnet. Let's say create public subnet. Okay, so the code would be this. Resource, we have already seen these codes in the previous videos. I don't need to explain again and again, so I'll just quickly go through this. So resource AWS subnet, this is a resource. It will create a new subnet, and the name which I'm giving is public subnet 1A. I'll just match with this name, yeah, public subnet 1A, and another name will be public subnet 1B. Okay, all right. So, and this is how we'll access the subnet information. Data dot availability zone here dot is dot name 0. See, 0 indexes is 1A, 1 indexes 1B. All right, and we'll keep this CIDR block 10.10 20.024, and the VPC ID. How to access this VPC ID? Again from here, VPC ID, right? Perfect. Let's do one thing. Let's close also, so that it will be easy to reference. Perfect. Okay, so AWS VPC dot dc1 dot id, and since this is a public network, so we need a public IP whenever instances are launched in this subnet. So we need public IP, so we can mention this. By default it is false, and then put a tag. So this is this is the first public subnet. The another public subnet in the similar way we need to create this way. So in this way, this will be public subnet 1B, right? This is the what in the diagram, public subnet 1B, right? Yeah. So the same way availability zone information, but this time the value will be 1. So this is in 1A, 1B. Okay, CIDR block will be 21. So 20 here and 20. So public will keep in 20 and 20 series, and private will give, let's say, 30, right? So let's create now private. So oops, let's create private subnet. Okay, so to create a private subnet, say from here we go. So similar way, just the CIDR block will get changed here. See, 30, and here also 30. VPC ID will be the same, and tags obviously I have changed it to private subnet 1A and private subnet 1B. Okay, and the AZ again 0 and 1. So this will get created in 1A, this will get created in 1B, and the names are private subnet 1A and 1B. So we are done till this step. So what we did, we created a VPC, we created internet gateway, we created elastic IP, we have created these 4 subnets in the 2 availability zone. Okay, perfect. Now what's the next step? So let's create a NAT gateway. So NAT gateway obviously will reside in public network. So any of the subnets we can create in either in 1A or we can create in the 1B. So let's create it in the say 1B. Okay, so there it go. Yeah, so the next step will be creation of NAT gateway. So how to create a NAT gateway? We say resource AWS NAT gateway, give any logical name. This name can be anything. This is not mandatory that the both names should be matching. If you see everywhere I'm matching these names, right? So it's not mandatory. So you can give any name whatever you want. This name will be accessed when you're using output. This name will be used as your tag. In the console you will see this name here. So when we create a NAT gateway, right, it will ask for the location ID. Location ID is what your is asking for the elastic IP. So we need to provide that IP, right? Let's close this so that we can get this information. Okay, so elastic IP, see how can we get the ID? AWS EIP dot EIP and then ID. This is what I'm referencing here, AWS EIP dot EIP dot ID. So this is the location ID. Then for which subnet, because we need to put this NAT gateway in any of the subnets, right? Either we can put in 1A or either we can put in 1B. This is my public subnet, so I'm putting in 1B. So you need to mention as a AWS subnet dot public subnet 1B dot ID. So this is your subnet ID, and that's tag. You can give anything what you want. So we are good with the NAT gateway, right? Okay, so all set. Now only thing is left is routing table, and then we need to associate these subnets with the routing table. So first we'll create a route table, and then next will be we'll associate these subnets to the route table. Perfect. Okay, let's go to the routing now. So if we go to the routing, NAT gateway is done. There we go for routing. So this is how we create a route. So by default a VPC will have a route table, right? So if you don't associate any resources with any routing table, it will go to the default. So what you are going to do here, we are going to create a two route tables. First will be your public route, and the other will be your default route, which will become your private subnet. So if we don't reference this, the resources will get created here. It will reflect for the private network. So let's see how to create this. So AWS route table, so the name I can give anything I want, DC1 private route. Then for which VPC, so VPC ID, this is how we reference VPC, AWS VPC, the name of the VPC dot ID, right? And then create a route. So what we are saying here, for this route table, anything, all the traffics, when you say 000.0 and /0 means basically you're doing all the traffic, you are redirecting to the gateway ID. So gateway ID where? This is your internet gateway which you have created. So if I just minimize all this and say where did we create internet gateway here. So how do you get the internet gateway ID? AWS internet gateway dot dc1izw dot id. Let's see here, AWS internet gateway dot dc1izw dot id. So basically what we are saying here, redirect all the traffic to the internet gateway for this route here. So this is the rule which we are adding here. Okay, and we can say the route table name as a DC1 public route because this is your public. In the similar way, there should be a default route. So as soon as a VPC is created, a public default route table is already created, right? So what we are assigning that ID for the private. So if you see here, so the name will be different for that. If you want, you can create a different route table altogether, and you can keep the default ID also. That's totally depends on you. But here what we are doing here, so instead of creating a new one, whatever default route table is created, we are assigning for the private. So the name will be AWS default route table, and the name will be DC route. You can give any name, and then default route table ID. So this value will get from where? When you create a VPC, right? Once you create a VPC, if you in the output you will see the AWS VPC.dc1 default route table ID will be key, which will have the route ID for that particular VPC. So this is what we are assigning for the default route table. Okay, all set. So we are good with the routing. Now the next thing is left is your subnet association. So if you remember on the console, let me see if we have anything. come on. Okay, so let's go to the VPC and now go to the route tables. Okay, I think we don't have any route table. So if you remember here, if you have a route table, if you select here, you will see you will see an option here to associate subnets to with this route table, right? So this is the last step which you perform here, right? So this is what we are going to do here, to associate these subnets whatever we have created to these routes. For example, here these two subnets will associate with this route table, these two will associate with this route table, right? So this is what we are going to do now. This is our last step, subnet association. All right, so the resource, this is how we create resource, AWS route table association. That's the resource. This is how Terraform creates a association, and then you can give any name you want. Then we need to provide the subnet ID and the route table ID. We need to provide the subnet and the route table where you want to attach. So I want to attach the public subnet 1A. This is the ID for that, and then on which route table I need to attach to this route table, right? So AWS route table, if you see, this is our route table which we have created. Just minimize this. This is your public, this is your private default, right? So AWS route table dot dc1 public route dot id. So what it does, it will associate this subnet with this route table. In the similar way we need to do for this also, so that both subnets will be associated with this route table, and we have put a route that anything comes with this to internet gateway redirect to the all the internet traffic will go to the via internet gateway, right? So basically all the instances which you will launch in these subnets, they will have internet access. So see here, the public subnet 1B and then ID, and to which route table, this route table. So AWS route table, same DC1 public route ID. So this is for your public, and the private, how you can access, same AWS route table. You can give any name whatever you want. This time the subnet will be what? Your private subnet ID, private subnet, this one, private subnet 1A and private subnet 1B, private subnet 1A and 1B, and the route table ID will be this, right? So route table ID will be again with the same name we can access here. See here, this is how we referenced what's the ID for that, so we can reference with this name. So all right, this is this looks good. Okay, let's save this file and push this code to the Terraform server so that we can do a deployment. Can get anything and just push this code. Okay, that's my Terraform server, and this is the where, see, the networking folder. Let me go here. Okay, all looks good. I'll do a Terraform init. Perfect, and then just do a Terraform plan. I hope we don't have any syntax error. Perfect. So this looks good, and we have so many things to launch. It says plan 14 to add. Now if you see, scroll from the beginning, you may miss something. So what you can do, there is multiple ways to do it. You can just do a grep and then say created, so you can see what all things are getting created. Perfect. So you can see here, so the route table, one EIP, okay, then internet gateway, then this is NAT gateway, this is your public route, perfect, and then 4 association rules, and then 4 subnets, and then 1 DC1. So this is one of the way. And if you want to save the plan also, what you can say, I think -out plan.out. So what it does, it will save this information in file called plan.out. Obviously you cannot read this, so if you want to read this file, you can say Terraform show and plan.out. So it will show you what all things it is going to do. So you can see the same information which I did grab, and I got all this information in the same way. I can get all this information. So again, VPC ID, 4 subnets, then 4 association rules, then one NAT gateway, one internet gateway, one elastic IP, default route, and public route. Perfect. This looks good. Okay, let's do a deploy. Terraform apply. Say yes. And just wait. I think it will take a couple of minutes to do it. I have pasted the complete code in the description of this video. You can find this complete code, and you can obviously modify according to your need or variables. Should be completed. Actually, the NAT gateway takes time to get created. So hereafter we'll be following in the same way. Now what we are doing right now, we are hard coding all the values here, right? So that's not the best practice. What we can do, we can like right now we are hard coding all the values here, the name, the cider block. We can reference via we can create a new file called variables.tf, and we can mention all these values. That's the best practice. We'll see in the next video how to do that, so that we can follow the best practice, how to keep and maintain codes. And the later will use networking as a reusable module, because suppose if you need to create EC2 instances, then RDS instances, if you keep on writing code in a big file, that's not that will be a messy, right? So what we'll do, we'll segregate code, and I'll show you how to do in the next video. I'll take the same example and I'll put in the variables.tf. I'll create another file, and we'll call these values from the variables, so that we can segregate our code, and probably we can put output also in the next file, and we'll see how to call all those things. We'll see in the next video. I think this is done. 14 added. Okay, perfect. Let's go and check. So your VPC, let's match from here. Okay, so we created a VPC. That's where we have 10.10 or 16. We have VPC. Then we have an internet gateway. Yes, you can see DC1 AJ1. See, your internet gateway is there and it's already attached to this VPC. Okay, perfect. Then we should be having subnets. Let's verify all these subnets. There we go. Private subnet 1A, then public subnet 1B, private subnet 1B, and okay, I think we have a missing A in our code. That's why it got missed. That's fine. We can modify manually. Okay, so this is our subnet. Then let's say we have our elastic IP, should be here. Yes, we have the elastic IP. And then what else? We have NAT gateway. Yes, we have NAT gateway, right? At the last, let's say the route tables should be two. Perfect. Public route and the default route, which is private. So public route the traffic should go to internet, right? Let's see the routes. Here we go. See, 0.0.0, it attached to the internet gateway, right? And again, the subnet association, I told you, right? We need to attach the subnets. You'll see this to public subnets here. In the same way for this default route, which is public. See 31. This is the public one, right? And routes, I have not defined anything. So this is all set, right? This is what this is what we were expected, and we have created this infrastructure via Terraform. In coming classes, we'll make this infrastructure more and more complex. We'll add more things like EC2 instances, RDS instances, auto scaling group. All those things will be keep on adding. So keep on watching these videos. Please subscribe if you have not subscribed, so that you will get updates whenever I upload a new video. And thank you all for watching this video. Thank you.